Friends, let's get ready for the next session. Are we ready? There is no sound, yes or no, ama, illa, nothing. Are we ready? Yes is very low, sir. Are we ready? I invite Ms. Sarika Joshi to the dais to take over the session. Welcome, ma'am.
Welcome back, everyone. It's a great pleasure for me to be here. And we will start the session number 4, which is the first session of today's. I would like to kindly invite to the session chairperson, Mr. Vivek Joshi, and esteemed speakers, Dr. Prem Motwani, Dr. G. Kulanthawai, and Mrs. Esther J.C. Could you please come on the dais? Please give them a big round of applause. It's quite interesting for me, and I'm really very fortunate to introduce our session chairperson, Mr. Vivek Joshi. Mr. Vivek Joshi has a bachelor's degree in metallurgy from Government College of Engineering, Pune. He has a master's degree in industrial and systems engineering from the Ohio State University, Columbus, Ohio, USA, and MBA from Indiana Tech University, USA. Mr. Vivek is also a Six Sigma Black Belt from North Carolina State University, USA. For more than a decade of professional career in the USA, Vivek worked in various functions at Ryobi Die Casting, including R&D, process development, quality, and engineering for the USA and Mexico plants. Mr. Joshi is practicing lean manufacturing and advanced problem-solving tools like DOEs, and were fortunate to learn from the leading professors at the Ohio State University and Juran Institute of Quality at the NC State University. Currently, he is the Director and Chief Executive Officer of Sundaram Clayton Limited. NIQR is happy to present Mr. Vivek Joshi as the chairperson for this session. And I would like to hand over the dais to him for his address. Mr. Vivek Joshi, could you please come? Thank you.
Respected dignitaries on the dais, respected dignitaries present in the audience, the NIQR's leadership team, and fellow attendees, a very warm good morning, good afternoon to all of you. I am very pleased to be here today to chair a session with very eminent speakers from different fields on a very, very crucial, important topic in front of not just the industries, but the entire India, considering the path that we are on. I always truly believed that the mantra for the next generation workforce is skill up the operators and de-skill the process. And this is not my mantra actually. This is taught to me by my late mentor, Sri C. Narasimhan. He used to always teach me that you must ensure that 100% plus efforts should be taken when you are skilling the operators, skilling the engineers, and skilling the future leaders. When it comes to the manufacturing process, though, it should be so simple, it should be so automated that it can run by itself. Now, a powerful combination of a highly skilled operator and engineer and highly optimized process that can run by itself can lead you to tremendous results. As you know, India is on the verge of scaling new heights in manufacturing with global supply chains rebalancing, initiatives like Make in India, Atmanirbhar Bharat, and the rise of Industry 4.0 technologies. The nation has the opportunity to become not just a global factory, but a global innovation hub. This vision rests solely on our workforce, spanning from machine operators, team leaders, setup techs, supervisors, engineers, managers, and the leadership team. Bridging the talent gap for the engineers and technical staff is one of the most dominant challenges that we are facing today. In fact, I was in a very advanced manufacturing company in Switzerland 6-8 weeks back. And it's a Bueller machine manufacturer. And they had a special session where we participated in understanding the skill gaps. There were invitees from Germany, there were invitees from France, so most of the Europe, including Italy, Switzerland, from US, some of us from India and China. Everyone talked about how the challenge of skilled workforce is the biggest challenge ahead of them. And fast forward, if you look at the factory of the future, you will not have the employees dragging material, carts, employees running large fork trucks. The robots are carrying the parts. Machines are connected and talking to each other. The data is automatically stored in the main server. Even the power that is getting consumed is monitored every minute and graphs are auto-plotted. All the work is done by machines, by robotic automation. The material is not stored all over the places, but it is stored vertically. The material is called at a push of a button. The orders are coming electronically. The process parameters are coming on the dashboards. And I am not talking about a future factory. I am describing a manufacturing workplace that Sundaram Clayton designed, built, and now under fully operation here in Chennai, right in the Thervai Kendigai SIPCOT. We are very proud of this brand new, what we call as lean, green, and connected factory, a smart manufacturing center that is one of the most pioneering in the field of die casting, not just in India, but in the world. And guess what? The biggest challenge that it is addressing today is the challenge of future workforce. We have a plant in US. In fact, I was there last week, visiting on the shop floor, talking to my employees there. Guess what? The biggest challenge in the US right now in scaling up the production is our workforce and the talent. United States used to have very good programs like journeyman program, wherein the operators were working part-time in the shop floor and part-time in the technical schools, getting the theoretical lessons. And this journey continued for 3-4 years, and at the end of the journey, they were skilled on the shop floor skills and aware of all the theoretical concepts that are required to perform their job. In fact, the shop floor skills are so important when it comes to actually how the workman sits. For example, if I am talking about a tool technician who maintains and manages dies, how do they sit? Are they sitting ergonomically? Are they putting a proper mag light on their work center? Are they getting right focus in the area? Are they using the right tool in the right manner? Are they applying right amount of pressure? And you know what? This kind of skilling is fundamental, right? In the traditional way, we can say, for decades we are teaching our workforce to go for this skilling. Today's technology, such as VR, the advent of virtual reality, and we have implemented that in our shop floors, where we can, before even the shop operator goes to the shop floor, we can actually take them through the process step by step. They can practice and they can actually visualize and they can actually perform digitally before the actual work physically can be performed. With the advent of AI, the machine learning, the data that is digitally coming across to the operators and engineers, it is important that we convert all these technologies from the manufacturing on the shop floor to the actual usage in the future. And there needs to be a lot of discipline from get-going. We heard the eminent speakers in the previous session where they talked about collaboration with industry, academia, as well as the large public sector enterprises. It is extremely important that such collaboration yields to the fundamental knowledge and higher skill levels for our workforce. The future workforce cannot be just anticipated, it has to be designed and engineered. Our chairman, who is our mentor and guide, Shri Venu Srinivasan sir, a pioneering name in the field of quality and TQM, he always tells us, please ensure that you take care of your workforce and the workforce will take care of your business. You take care of engineers and leadership team, they will take care of the future of the company. He also ensures that everything that you are doing on the shop floor is systematically pre-designed in a digital space, and then you can implement it in the physical way. So in fact, if you visit our factories at TVS or Sundaram Clayton, you will see our kitchens are also fully engineered. The way the raw vegetables will come, where the dry cutting will happen, where the washing will happen, where the storage will happen, we have spaghetti diagrams for every activity that we do at the elemental scale. Such is the depth and understanding that we need to start with, and for the future, obviously, a lot of work has to be done in the space of artificial intelligence, in the space of machine learning, and they are interacting with each other at multiple scales. For example, if you are talking about the TPM, it is no longer a maintenance, breakdown maintenance or preventive maintenance. It's no longer a time-based or activity-based maintenance. it is progressing towards the predictive maintenance. It is progressing towards, even before predictive maintenance happens, can machine correct itself and give the parameters that will correct the program. So we should be talking about a digital loop where a parts, for example, a dimension is already checked. That dimension, they see the trend is going in certain direction. Machine comes to know, hey, if I don't take action now, 5th or 10th part from now will be going towards the out of control loop. Machine takes that signal, either makes a adjustment or ask for a tool change, or ask for, say, if it is a heat treatment process, ask for the temperature changes. Such is the closed loop system that parts will be auto-corrected even before they are produced. That's what we are talking about, the future of workforce. So with this, I think engineering a future-ready workforce, we need to look at the way forward. In terms of industry, we must invest in training, academics, and digital learning. We should collaborate with government. There are many programs the government of India are bringing, and especially in Tamil Nadu, you see that lot of work is being done by government of Tamil Nadu in terms of Skill India and incentive skilling. The programs like Pay for Skill that you can do yourself in your factories. There must be a very close loop collaboration between the academics and the modern factories, where the curriculum of the academics can be co-designed and co-developed with the help of the industry. Employees must own their learning journey. It never stops with somebody else doing the work for you. We were on a Japan study mission few months back, and 10 days we worked in various areas of Japan. We went around and saw. We looked at their Shinkansen cleaning areas, we looked around their post offices, we looked around where they are disposing of their waste, how they are managing that. We also visited one of the schools, and it is an eye-opener and life-changing experience if you visit a Japanese school live in action. How the kids come together and clean their areas, how the kids come together and help each other serving food. And this kind of what we call in Sanskrit samskaras are given, inculcated. So I don't think Japanese companies, and I worked with many Japanese professors and mentors and bosses, they don't need to be taught 5S in the factory, because 5S is inculcated in their lifestyle whenever they are working in their home or in their school. So a lot of work can be done right from the beginning, and employees must own this journey of self-learning, curiosity, and commitment. Today we offer a lot of digital courses to our employees, and employees go online and then learn by themselves. If you ask your children today, how did you learn something? And they will, most of the time they will tell you, I learned it by myself. So the concept of some teacher teaching is actually changing rapidly with the advent of all these digital technologies. And above all, this transformation must be inclusive. The future of work must not leave anyone behind. So I suggest engineering a future-ready workforce is not just about preparing for tomorrow's jobs. It is about shaping our country's destiny. If we invest in confidence, if we invest in competence, if we invest in the creativity, India will not only be the world's manufacturing hub, but also the manufacturing leader. We saw what China has done. I'm sure with the kind of talent sitting here, the kind of technology that we are exposed to, India is, although it seems far behind, what Mr. T.K. Balaji has mentioned in the morning, leapfrogging, we must go through those breakthrough solutions. We must leapfrog and help Bharat become the manufacturing leader. The workforce we shape today will define the India and build India of tomorrow. Let us engineer it with our vision, courage, and responsibility. I am very happy that we have very eminent speakers here. I didn't want to dwell into the subject too much. I didn't want to steal their thunder. We want to take the knowledge from them, understand and learn from them, and I'm sure you will enjoy this very interactive and very crucial session on the future skilling. I request all of you to pay full attention and look forward to good questions from you at the end of the sessions. Thank you.
Thank you very much, Mr. Vivek Joshi. That was really an enlightening speech. It comes from over 30 years of experience in the manufacturing. And thank you very much for setting the context for this session. And it's a great privilege for me to introduce Dr. Prem Motwani, who is a professor at Jawaharlal Nehru University. Dr. Prem Motwani is an alumnus of Delhi University and JNU. He has visited Japan close to 80 times and lectured at many universities. He has lectured at Nikkei BP Business Seminar as a regular faculty. He was visiting professor at Hiroshima University and was director at the Japanese School, New Delhi, for over 15 years. He has been awarded the prestigious Harsha Award by ISQ in 2023 for guiding companies in the journey for quality excellence. He was awarded the Order of the Rising Sun Gold Rays with neck ribbons by the Japanese government in the autumn 2020 in the recognition of his contribution to promoting academic exchange and mutual understanding between Japan and India. He was awarded Japanese Foreign Minister's Commendation by the Japanese government in 2015. NIQR takes pride in presenting Dr. Prem Motwani for this session, and I kindly request Dr. Prem Motwani to be here to deliver his most awaited speech. And it's great to be here, Dr. Motwani, and it's a pleasure to meet you again. I have met him in Japan last time, and we are closely, associated through ISQ. Thank you very much, Dr. Prem Motwani. Please give him a round of applause.
Yeah, thank you very much for your kind introduction. Respected members of NIQR, distinguished guests, ladies and gentlemen. It's a great honor to be speaking here again. I was here earlier this year in the NIQR seminar where I delivered a talk. I would just like to add that since I have been an academic all my life and a student of Japan, I have never worked in the industry, so talking to all the professionals, all the practitioners, from a third person's perspective. Like, though I have been an academic, I have specialized on Japanese economy and Japanese management. And that is where my meeting point with the industry started. And through the Deming audits and TPM audits, I have been associated with a lot of companies. And that, got me interested into, finding out in more details. Theoretically, I knew Japanese management, but practically, how it is being implemented here. So I visited Japan close to 80, 90 times. And each time I visited Japan, I visited a lot of companies through JUSE and JMAC, and saw, how they were implementing the same methodologies. So that actually revealed to me that there is a big gap, and obviously it's the cultural difference, so it is bound to be different. My role always has been to to act as a bridge between India and Japan. So from that perspective, I would like to really talk today also. So the title of this is Role of Engineering in the Digital Age. Do I operate myself, or can you go to the next slide, please? Okay. So these are the contents of my presentation. Now, typical role of engineering. I have not gone into too much of detail, but basically when you say the production engineering, when you say engineering, I believe it is production engineering. So you do product process designing and development, and then the documentation. You have product and process validation, work process design, die, jig, tool design, maintenance, then drawings and technical standard management, and new equipment introduction and organizational learning. I mean, these are broad kind of tasks that any production engineering performs. And in addition to that, you have some of these other tasks to be performed, like early participation in concept and prototype design reviews. You have change management, DFA, DFM,